Hi everyone, welcome back. Lesson 3 of the circuits lecture series, and today we are going to do a power example. So I actually forgot to mention in the last video when we talked about power is measured in watts, okay, and it's denoted with a W. If you want to know how to spell it, W-A-T-T-S. Now, we are given this extremely simple circuit. It just has a 2 ohm resistor and an 8-volt battery. And basically, we want to use Ohm's law to calculate the current I and the power. Now, we are going to get V equals IR. Write down the Ohm's law, and we're going to divide both sides by R so that we get I in terms of V and R, because we have those two values, 8 volts and 2 ohms. We're going to plug it in. 8 over 2 equals 4 amps. Now, notice something important, okay? We found the current that's going across the resistor. How? How do we know that? Because it's positive, okay? Now, as you get better and better at doing these things, I was very confused about this when I was first doing circuits, but when you have a simple circuit like this, it's kind of implicit to know that when you just have this battery source, you're gonna get a current going out and then the current going into it. And as I had explained in last lecture, you could probably figure out why. It's because when you have a current going into a power source, right here, it's negative. And what does the negative power mean? It means that it's generating. Whereas here, we have a passive sign convention, and resistors are always going to have a positive power, right? And so we know that the current is going through the resistor, and it is positive. So just a little tip there. You don't have to think about it that hard, but that's just how it is. So I just said and calculate power, which is super vague. Right now, we're going to just calculate the power from this guy, and then, dissipated, power dissipated, because passive sign convention, it's a resistor. That's what resistors do, is dissipate power. And then we're going to calculate the power of this guy right here. So, the power as seen by the resistor, or dissipated by the resistor, is going to be I squared times R, or V squared over R, right? Because we need we need the R in this equation, or we can't find the power of the resistor. So, plugging in our values, we've got 4 amps here times 2 equals 32, and we've got 8 squared divided by 2, which equals 32. So, see, they check out. Now, let us find the power of the battery, or if you want to be more specific, 8-volt battery. So here we're going to use IV, and remember what I said, the more complete version is P equals plus or minus IV. Now, what do you think? Will this power be positive or negative? I kind of gave the answer already. It's going to be negative, because it is distributing that power. It's generating that power that will be dissipated. So, and also you can see visually right here that the I is going into the negative n, where the I here is going into the positive n, just like so. So we're going to do negative 4 times 8 equals negative 32. Now notice something important here. These are the same magnitude, but they are different in sign. And so the next question is, prove conservation of power is upheld. Now, we said that the conservation of power is the sum of the p's must equal 0. And so, in this case, we get the sum of the p's equals p 8-volt battery plus the p of the resistor. And what do we get? Well, we get negative 32 plus 32 equals 0. So we know that we did this right, and we didn't invent energy, right? Or invent any power. No, there is a loss of power into the system, but there is no magic power coming in and out. And this is how you know that you are correct. If you have the chance, always, always, always check power and see if the sum of all the powers equals 0. That will save you a lot of mistakes on exams. All right, that's it.